number of particles in a cubic unit cell. To calculate the number of particles per unit cell for primitive and non-primitive cubic unit cells. A primitive cubic unit cell has lattice points at the corners of the cube only, while a non-primitive cubic unit cell crystallizes as body-centered, having lattice points at the corners of the cube as well as at the body center. And face-centered cubic lattices having lattice points at the corners of the cube as well as at the center of each face. Here, we will calculate the number of particles per unit cell for all the 3 cubic lattices one by one. First, let's consider the simple or primitive cubic unit cell. Polonium metal is an example which crystallizes in the simple cubic unit cell. This implies that 1 atom of polonium is present at every corner of its cubic unit cell. On a close observation, we find that every corner atom of this unit cell is shared by 8 neighboring unit cells, 4 on the same plane and 4 on the plane lying above it. Thus, only 1/8 portion of every polonium atom is actually present within the unit cell. As 1 polonium atom is present at every corner of a unit cell, 1/8 of each polonium atom is present within the unit cell. The actual picture of the unit cell looks like this. If we add all these 1/8 portions, we get a single polonium atom. Thus, there is 1 atom per unit cell in a simple or primitive cubic unit cell. Let's now calculate the number of particles per unit cell for non-primitive cubic unit cells. Consider the body-centered cubic unit cell. For this, we will consider metallic sodium as an example. The unit cell of sodium has lattice points at all corners as well as at the center of the cube. This means that there are 8 sodium atoms at the 8 corners of the cube and 1 sodium atom at the center of the cube. As in the case of a primitive cubic cell, only 1/8 of each sodium atom present at the corner actually lies within the unit cell. However, the atom at the body center is not shared by any other unit cell. It lies completely inside the unit cell. The actual picture of the unit cell of sodium metal looks like this. Thus, the total number of atoms per unit cell is equal to 8 multiplied by 1/8 for the corner atoms plus 1 present at the body center. Therefore, the total number of atoms in body-centered cubic arrangement is 1 plus 1, that is 2. A body-centered cubic unit cell has 2 atoms per unit cell. Now, let's consider a face-centered cubic unit cell. For this, let's take silver metal as an example. The silver atom crystallizes in the face-centered cubic lattice. This means it has lattice points at all the 8 corners as well as at the center of each of the 6 faces of the cube. We know that the silver atoms at the corners are shared by 8 neighboring unit cells. Thus, only 1/8 of each silver atom at the corner actually lies within the unit cell. Now look at each face of the unit cell. one half of the silver atom present on the face center lies within the unit cell, and the other half silver atom lies in its neighboring unit cell. The actual picture of the unit cell looks like this. As seen earlier, the corner portions of the silver atoms add up to give one silver atom. The 6 half-silver atoms present at the faces add up to give 3 silver atoms per unit cell. Thus, a face-centered cubic unit cell, like silver, has 4 atoms per unit cell. Summary. We have thus studied that a simple cubic lattice has 1 particle per unit cell. A body-centered cubic lattice has 2 particles per unit cell. And a face-centered cubic lattice has 4 particles per unit cell.